morning. My name is Sowmyan Rajagopalan, founder and CTO of Thalia Design Automation. In today's presentation, I'll be talking about why analog IP reuse is a big problem for a number of semiconductor companies, and then about who Thalia are, our value proposition, and I'll close the presentation with a case study. So what you see here is a classic decision fork that a number of semiconductor companies face. On the left, you have the need to build new IPs, and on the right, build a portfolio of existing IPs. New IPs obviously driven to address new sections of the market, dramatically increase the revenue, and obviously it is exciting for designers to work on newer products. Building a portfolio of IPs allows a company to expand within an existing market, stabilize and increase the revenue as well, widen the customer base. But obviously, this is not an either-or situation, largely because the cost of addressing both designing new IPs and building a portfolio could be pretty high. And the number of qualified good analog designers are also limited. So this is a conundrum. Circuit design is impacted by a number of factors. They range from device performance to technology characteristics, market needs, and finally design methodology. So what this results in is an IP reuse of an analog circuit essentially becomes a circuit redesign. So even circuits like band gap results in a complete redo, which obviously is not the efficient of approaches. And now add to the fact that there are limited, credible, complete solutions in the marketplace, and the fact that good design engineers, tend to be very limited. This makes a difficult problem worse. So it then begs the question, is efficient analog IP reuse a myth, a dream? At Thalia, we are bringing about a paradigm shift in the way analog IPs are reused. We've deployed a unique framework called the Amalia IP Reuse Platform, which is leveraged to efficiently and cost-effectively reuse IPs existing with a number of semiconductor companies. This platform constitutes of three elements, which we call the trifecta. The first is the proprietary design automation technology. The second, innovative design methodology based on design approach rather than CAD-based or synthesis-based approaches of our competitors. And finally, a very capable design, experienced design base within the company. It's through the amalgam of the three elements that we are able to deliver IPs in a short period of time efficiently and cost effectively. A bit of a background about who Thalia are. I founded Thalia back in 2011, and the premise for founding Thalia is largely to improve the overall efficiency and the cost to reuse analog IPs. Since then, we've expanded the technology that we've been building and developing in-house to address a number of technologies and nodes. We've expanded in India and now in Germany. We're also partners, IP reuse partners of choice with a couple of IP companies in this continent. As part of our offering, we address multiple market requirements, customer needs. The first one being IP migration, which is essentially moving an IP from one technology or a node to another technology or a node. The other one being if you want to create a multitude of flavors of an IP, whether it is building different load currents of a regulator or different frequency of a VCO or a PLL. So this is something we are able to deliver using our the trifecta I talked about earlier to customers. We are also able to address and improve the PPA as in power, performance, and area. So this is something we are able to deliver using the technology. And then IP hardening. This is the case of improving the quality of existing IPs so that it better meets the customer requirements. And this is done on the back of technology, the methodology, and design expertise. Why are we different? Unlike anybody else in the marketplace, what we bring about is a unique combination of proprietary technology, which is built on the back of AI algorithms, addressing all aspects of the design flow, along with innovative design methodology and smart resources. It is this combination an approach that leads to increased speed with regards to moving an IP from one technology to another, or building the portfolio, and hence the lower design cycle time, and hence the lower cost. A quick background about our technology. So we have 4 tool sets that address technology that address all aspects of the design flow, starting from analyzing the technology all the way to layout. So the first one here, which is part of the Amalia IP reuse suite, is called the Automated Technology Analyzer. I'll talk a bit more in the upcoming slide, but primarily what we do with this technology is to quickly analyze devices in technologies or different nodes and come up with the best map. So the next slide, I'll talk more in detail about this. Once this analysis is done, this data is fed into the automated schematic porting software, which migrates the design schematic from one process node or technology to another, factoring in all the key metrics like sheet row, unit caps, the min-els, and various other things. Once the schematic has been migrated to a different node technology, then we have this capability called Design Enabler, which is able to nudge the design back into requirement, back into specification. We also deploy this along with design expertise when we are in the process of improving the power, performance, or area of IPs. The last bit is layout migration or layout automation, which is about creating a baseline structure for the layout in a new node or a new technology. Okay, so the earlier slide I showed you 4 different offerings of the Amalia IP reuse suite, and the technology analyzer, which is a big differentiator between us and the competition, or for that matter, the standard approach that gets deployed in the IP reuse framework. So ours is a very design-based approach. So when devices are mapped between one technology or a node to another, it is not based on just the number of terminals. It is actually a lot more design-centric in the sense that device-based simulations are triggered, through using the methodology we have developed in-house. And we compare the VTH, GM ID, IDS, VDS curves are looked at, and then once the first order and second order effects closely match, we then identify and pick those devices, as the ones that could be mapped into the target technology or target node. Using the approach that we take, what happens is that the circuits in the target technology are that much closer to the base design, and this reduces the number of iterations and hence the design cycle time. So as part of the case study, I'll go over a Bluetooth 5 IP, which we migrated down to 22 nanometer SOI. So the blocks you see here are standard blocks that are present within a Bluetooth IP. In today's case study, I will focus on one of the blocks listed at the bottom, RCO. So what you have on the screen are the constituents of the RCO block. The specification is listed on the top right of the slide, and at the bottom you have the blocks that constitute the RCO, the comparators, the RC filter. We'll focus more on the comparator because this is where the impact of technology difference was identified. So one of the differences we noticed was the difference in VT between the base technology and the 22SOI. In 22SOI, the VT of both the InFET and PFET were higher than the base technology, and this resulted in headroom pressure, which meant that the section of the circuit marked in red in the picture on the right were being pushed to threshold and sub-threshold. Not an ideal situation. So how do we address this? Maintain the drive by increasing W and increase the area. That's the standard approach. The alternative is, since the technology offered flip-well devices, is to use them and change the VSB to reduce the VT, which is the approach that we took, and leverage the back bias capability of 22SOI technology. Our mantra is complete automation in analog circuit design does not work. Targeted automation works, and what you see on the screen are various snapshots of the automation process during the course of migrating the design from the base technology to 22SOI. So what you see on the screen are the results after the circuit was tweaked, the device updated, and backgate biasing feature leveraged. So what you see are tabular columns of the circuit characteristics. On the left are the characteristics in the base technology, and on the right are the characteristics in 22SOI. As you can see, the circuit now meets the requirement in line with the base design. The circuit was simulated and the layout verified, and the IP was taped out. Thalia are pioneers in deploying the trifecta I talked about earlier in the presentation. That is, this unique combination of technology, methodology, and design expertise. So we are partners of choice with a couple of IP companies, and what you see on the screen are the improvements to the design cycle time that we bring to the table. These are representative numbers. Obviously, the numbers vary depending on the complexity and the process technology requirements. But what you do see is that we bring time savings in the order of 30 to 40% compared to the conventional approach. And what you see on the screen is one of our partners. So we've worked on a number of Wi-Fi's and Bluetooth IPs, and we have delivered silicon validated solutions to this customer. And as you can see here, there is an acknowledgement of reduction to the design cycle time and improvement to efficiency that we have brought to their design flow. To recap, we've successfully deployed an analog IP reuse framework called the Amalia IP reuse platform. And this platform is a unique combination of technology, methodology, and design expertise. And using this trifecta, we've successfully delivered a number of IPs to our customers, both baseband as well as RF, and in the process, we've successfully reduced the design cycle time and the cost by up to 50%. We have a track record across a number of nodes and process technologies, and if you have any questions about how we can support and help you in achieving and improving the efficiency of or in the reuse of existing IPs within your company, please get in touch with us.